Hello. Hi, Hari. Hi, Shivnarana. Can you hear me? Am I audible?
Yes, sir, you are audible, sir. Audible.
Hey, nice. Good evening. We'll just wait for 3, 4 minutes more, 2, 3 minutes more at least, for the others to join, and we'll start the session.
Okay, sir. Okay.
In the meanwhile, if anyone has any questions, also you can let me know, guys.
Okay, sir. Okay.
Shivnarayan, is this your first class, or did you join the session yesterday?
Hi, no, this is my first class.
Okay, cool. No worries, no problem. So all the other sessions that I've been taking up until now, I think I've taken one workshop on Sunday, and we took a session yesterday where we covered basic networking fundamentals. Okay, so again, an important prerequisite for cybersecurity. So we talked about what networking is, what are networks, what are hosts, okay, and what are IP addresses basically. Okay, what are IPv4 addresses? What are the properties of IP address? What's the first IP? What's the last IP? Range of IPs. Okay. And then we
Okay.
covered the sequence of IPs and the categories of IPs. So we talk about what public and private IPs are. Today, I'll be discussing what classes are. Class A, Class B, Class C, Class D, and Class E. So again, a brief intro, just a recap on what we covered yesterday. Just in case, if you want to watch that video, it's available on the official channel of DurgaSoft on YouTube itself. So you can access the recording from there and you can go through the recording as well. Okay. So if you have any questions after you go through that, you can still let me know in the next session. Okay. Today,
Okay.
classes and some important networking protocols.
Sir, I did not join workshop, sir. Whatever.
That is also available in the YouTube channel itself, Srihari. Basically, we covered the entire course content curriculum piece. So I explained what we'll be covering throughout the course. So what is hacking cycle? What is the procedure? Some background disturbance. But yeah, so basically what we try to learn in the workshop is what is the hacking cycle? Hacking cycle in the sense procedure that is followed by hackers or ethical hackers to perform penetration testing. So there are 5 important steps in it. Explain what the 5 steps are, and briefly we discussed what topics will be covering throughout the course. Okay, so uh, just a glimpse on the
I will
entire.
check. I will check, sir. Okay. Okay, sir.
You can go through that. Again, if I just show it right now, one second, let me just go to my browser here. And in YouTube, we can search here for DurgaSoft cybersecurity. You can filter it out here. Just a second. Yeah. So filter it out with the recently uploaded tab. And you can see this was the seminar, the one which I conducted day before yesterday. Okay. And this was the demo which I conducted yesterday. Okay. So this is the workshop recording. And this is the recording from yesterday's class. Okay. Is that clear?
Sir. Okay.
All right. Hi, Sohit. Can you hear me? Am I audible?
Oh, yeah, sure.
Okay. Okay, guys. So yeah, let's get started. I guess everyone is here. So in today's class, as mentioned earlier, we'll be continuing exactly from what classes are. So in the last class, we have covered the 5 separate classes and their ranges. So we talked about the range of class A, class B, class C, class D, and class E, and the public and private IP ranges as well. Okay. Today, we're going to talk about the relevance of classes. Why do we have 5 separate classes and what's the importance of each class? Okay. So each of these classes has a unique network and host portion, guys. Class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Class D and Class E have all network portions itself. Okay. So as you're going down the line, network portions are increasing in number and host portions are decreasing in number. Okay. Class A has 1, Class B has 2, Class C has 3, Class D and Class E have 4. But what are these network portions and what are these host portions? What do they signify? To understand this, let's take the example of Class C first. So in Class C, you have 3 network portions and 1 host portion. Okay. And where does Class C's private IP begin, guys? It begins at 192.168.0.0. So that's the first private IP in Class C. If we go back to the same notepad, which I was referring to yesterday, 1 second. So yeah, I've written down the sequence of IPs here. So if I go back to this Class C now, if you notice, in Class C, it has 3 network portions and 1 host portion. Okay. And in that, the first IP is 192.168.0.0. First 3 octets here are the network portion octets. Last octet here is the host portion octet. Now, after 00, what's the next IP? You have 01. Next IP, 02. Next IP, 03. Next IP, 04. This goes on all the way up to the number 0255. Now, once the rightmost octet is completely filled, once you have 255 here, that cycles back to 0. And the next 0 now changes to 1. Okay. So then you have 10, 11, 12, 13, which goes up to 1255. Then you have 20, 21, 22, 23, which goes up to 2255. Okay. So that's the sequence. We covered this yesterday. Okay. Now, what I mean by network and host portions is that as long as the host portion changes, it signifies that each of these is a unique host, okay, belonging to the same network, 192.168.0.network. So the network portion gives the identity for that unique network, okay, and the host portion gives the identity for that unique host in that network. So this could be my Wi-Fi router, this could be my phone, this could be my laptop, this could be my smartwatch. Each of these IPs is given to each individual host in the same network. But when a network portion changes, when the 0 changes to 1, so whenever there's a change in the network portion, that divides the network there, which means now this network ends here. And from here on, we have a new network altogether. So from 10 to 1255, that's a separate network. And what I mean by different networks is if you bring this device 1.1 and connect it anywhere here, it will not be able to communicate. Because again, IPs can only communicate when they belong to the same network. So in each network, therefore, in Class C, you can connect a maximum of 1 to 255, a total of 255 devices. So even here as well, between 10 to 1255, you can connect another 255 devices. So I'm not including the 0th IP. It's called the network ID. You shouldn't include the 255th IP as well. It's called broadcast ID. But just as a rough figure, I'm again rounding it up to 255. So in each Class C network with 1 host, you can connect a maximum of 255 devices, not more than that. Okay, so that's what Class C signifies. Okay, so if I go back to my presentation slide here, in each network of Class C, if you notice from 00 to 0255, 10 to 1255, 20 to 2255, and finally 2550 to 255255. In each network, we can connect a maximum of 255 IPs, not more than that. That's what Class C signifies with network portions and 1 host portion. Okay. Is that clear? Shiv Narayan, Srihari, Sohit.
Yes.
Right. Moving on. So now once you know, again, same logic applies for other classes also. So Class B now has 2 network portions and 2 host portions. Oh, Srihari, any questions? I think you unmuted your
Yes,
mic.
sir. No, sir.
Sohit, any questions on your regarding Class C?
No, no, sure.
Okay. Right. Moving on. When you talk about Class B now, it has 2 network portions and 2 host portions. So same exact logic As long as the host portions are changing, they belong to the same network. Whenever there's a change in the network portion, that signifies a change in the network as well. Okay, so from 1600, so the first IP in class B starts at 172.16.00. Okay, first two octets are the network portions, last two octets are the host portions. So after 00, you have 01, 02, 03, 04, goes up to 0255. After 0255, you have 10. Now please note the network doesn't divide here. Okay, even though the third octet changes, since it still belongs to host portion, after 0255, you have 10, which can still communicate with the other devices. Okay. Then you have 11, 12, 13, 14, which goes up to 1255. Then 2021, 2223, which goes up to 2255. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 2550, 2551, 2552, 2553, up to 255, 255. Now, once both these octets are filled, now 16 changes to 70. And these 255s cycle back to zeros. So same logic. As long as the host portions change, each of these just represents a unique host, okay? A separate host or a separate device belonging to the same network, 172.16. When this network portion changes, when 16 changes to 70, that signifies a change in the network altogether. Okay, so this is the last IP in the 16 network, and here begins the 17 dot network. Okay, so from 1700 to 17.255.255, that's a separate network. 1800 to 18.255.255, a separate network. 1900 to 19.255.255, a separate network. And finally, 3100 to 31.255.255, that's a separate network. This is the last private IP in class B. Okay, and thereby in each class B network, you can connect a maximum of 255 into 255 IPs. Since you have two host portions, 255 into 255, which is approximately 65,535 devices. Just an approximate number. Okay, and finally, when you come to class A, it has one network portion and three host portions. So starting from 10.0.0.0 all the way up to 10.255, 255, 255, all of these belong to one single network itself. Okay, and in this one single network, you can connect a maximum of 255 into 255 into 255 IPs, which is much larger compared to class B. So logically speaking, in each class, you have this range of IPs that you can connect, guys. Class C can be used for small networks. So for home network, small organizations, where you don't have a requirement for connecting more than 255 devices, there you utilize class C. For networks which have a requirement for connecting more than 255 devices in each network, okay, so there you go for class B or class A, anything. Okay, logically speaking, you can connect these many IPs, but in practicality, that is not possible. You would have latency issues. But again, logically speaking, these are the differences between each class. Class A connects 255 into 255 into 255. Class B, 255 into 255. That's it. Class A, only 255. Oh, sorry, Class C, my bad. Class C, only 255. Okay. So each class is unique to the number of devices it can connect in its own network. Okay. And Class D and Class E do not have any private IPs in them. All of them are public IPs itself, but these are special public IPs. So these public IPs are never assigned to any, again, any ISP. They're used for research and development, for military purposes, for weather forecasting services, for, I think, government portals. Okay. For anything else? Yeah, again, for various government organization portals, etc., etc. You go for Class D and Class E. These IPs are used for these special organizations and never given to the general public, general users like us. Okay. So that's what Class D and Class E are used for. Okay. Any questions, any doubts regarding what IPs are used in which class, or again, what each of these classes signify? Anyone? Okay. I hope it's clear for everyone. Muktesh, Narayan, Srihari. So
Yes.
Yes.
perfect. Moving on. Let's talk about how do you assign a private IP. So before we learn how to assign a private IP, if you remember, we learned how to check the private IP in the last class. So if I type ipconfig here, this shows me my system's private IP. So right now my system is using a class C private IP, 192.168.0.3. That's my private IP here. Okay. But under that, I can see two other pieces of information. There's something called subnet mask and there's something called as the default gateway. Now, what are these? What does subnet mask mean? And what does default gateway mean? Okay. So to understand subnet mask, guys, this is for the computer to understand which IP belongs to which class, basically. So for us humans to understand which IP belongs to which class, we have network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. But how does a computer know which IP will contains how many network and host portions? So for that, the computer uses something called subnet mask. It assigns the network portion with the value of 1 and the host portions with the value of zeros. So in class A with one network portion and three host portions, subnet mask is calculated by putting all ones in the first portion and all zeros in the last three portions. Okay. And when you convert that from binary to decimal, all ones is 255 and all zeros is simply 0. So subnet mask for class A with one network portion and three host portions is 255000. For class B with two network portions and two host portions, subnet mask is 255 25500. And for class C finally, with three network portions and one host portion, subnet mask is 255 255 2550. So when a computer sees a subnet mask like this, it understands that, okay, this IP belongs to class C. And from that, I can only connect a maximum of 255 IPs. It understands the range of its network from the subnet mask. Okay. So subnet mask is for a computer to verify or understand which IP belongs to which class. And from that, understand the range of its first IP and the last IP. Okay. And default gateway is just a fancy name given to your Wi-Fi router, which acts as a gateway between the private network and the public network. If you remember this diagram here, I think yesterday I've shown you this diagram, this one, yeah. Okay. So when any of these devices here want to communicate with the internet, they always have to send the packet to the router here. So this router is acting as a gateway between the private intranet network and the internet network here. Okay. So therefore, it is called the default gateway. The device, which is packets which are sent defaultly to access the internet or vice versa, is known as default gateway. Okay. And that usually gets the first IP in the network. That's why even in my network as well, if I check the default gateway, it's 192.168.0.1. Okay. And please note, you never assign the 0.0th IP or the 255th IP. Those are called as network IDs and broadcast IDs. They are never assigned to any system. So the only usable IPs you would have is from 1 to 254. Okay. So those are the only usable IPs. Okay. Right. Moving on. Let's talk about assigning an IP address now. So coming over here. Right. So when you talk about assigning a private IP to your system, guys, there are two methods in which that can happen. One, you can assign it manually yourself from the control panel, or two, you get it automatically with the help of something called a DHCP server. Okay. If you have to assign an IP manually yourself, you first have to go to your control panel. In that, you go to network and internet. In that, you go to network and sharing center. In that, you go to change adapter settings. You right click on the adapter. You go to the properties. Then you click on IPv4 properties, and then you specify the IP address. If I show you this practically, I can open up my control panel here. In the control panel, I go to network and internet, network and sharing center, change adapter settings, right click on whatever adapter you want to assign the IP for. Let's say my Wi-Fi adapter, properties, IPv4 properties. And here I can assign the IP. So right now I'm getting the IP automatically, which means I'm getting it from my DHCP server. But if I had to assign it manually, I select the second option here and assign the manual IP here. 192.168.0.100, let's say. Okay. For this, since this is a class C IP, subnet mask is 255.255.255.0. And the default gateway is my router's IP, 192.168.0.1. Okay, so I'm giving a random IP here, guys. Okay, you could use any other IP of your choice as well. And you have to also specify something called DNS server addresses. So your system, when it needs to connect to the internet, it needs the DNS server IPs as well. Okay, don't worry, I'll explain about DNS servers in a bit. But just in case, if you don't know what to enter here, you can always go to your browser. And oh, 1 second, my browser is inactive. And in your browser, you can do a quick search here. Google DNS server IP. And that shall provide you two IP addresses. 8.8.8.8 or 8.8.4.4. So these are globally accessible DNS servers provided by Google, which can be accessed for free by anyone. Okay, so just in case if you don't know what to enter here, you specify those two IPs, 8.8.8.8 and 8.8.4.4. And as soon as I click on OK here, my system's IP would change to 0.100. Okay. Right now, I won't be doing that because if I do so, my system's IP would change and I would have to reroute my entire connection. So we would get disconnected from Zoom. Okay. So let's not do that now. Okay. But this is the way to actually assign an IP manually. Okay. So if you were the network admin in the olden days, and if you had to assign the IP to each system, you would have to go to each device here and assign the IP, a unique IP to each system this way. Okay. So if it's a small network, that's pretty easy, not that complex of a task. But if it were a larger network, like a class B network or so, in such a scenario, going to each system and assigning an IP is quite troublesome. That's why, to make it easier, we have something called a DHCP protocol. With this one single click of a button, my system automatically gets an IP. Okay. So how does that happen? What is a DHCP server? And what is this DHCP protocol? Let's talk about that. Okay. Now, as mentioned, when you talk about DHCP, this is an automatic method with which, again, your system gets an IP assigned. Okay. DHCP stands for Dynamic Host Configuration Protocol. Okay. From the name itself, you can figure out what it does. It dynamically or automatically configures an IP address to every host in the network. And that happens with something called a DORA process. So in your network, when you have a DHCP server, that server has a pool of free IPs. And from that pool of free IPs, it assigns a unique IP to each system using the DORA process. Now we're going to discuss what this DORA process is. Okay. So in our home networks now, our Wi-Fi router itself acts as a DHCP server, guys. So don't get confused. You might assume, you might have a question like, where is the DHCP server in my local home network? So your Wi-Fi router itself acts as a DHCP server. Okay. But what is this DHCP server and how does it work? And what is the DORA process? Let's talk about that. Okay, so let's assume this is my Wi-Fi router or my DHCP server. Wi-Fi router or my DHCP server. Okay, and this gets the first IP in the network, 192.168.0.1. Okay, and as mentioned, your DHCP server always has a pool of free IPs here. Okay, so from 192.168.0.2, 192.168.0.3, it goes on to the last IP, 0.254. Okay, so please remember the last IP 192.168.255 is never assigned to any system. This is called the broadcast IP. Okay, so this is called as broadcast IP. I'll explain what it means by that. Okay, so whenever this device is connected in the network, okay, so if there are new devices connected, your DHCP server assigns a unique IP from the pool with the DORA process. Okay, so the system might get an IP like 192.168.0.2. This could get 192.168.0.3. And whenever an IP is assigned from the pool, that IP is removed again. So you don't have the same IP in the pool again. So now the pool begins at 0.4, 5, etc., etc. Okay. So let's assume I bring one more device in the network now. Okay. So let's say we'll put this aside. I have one more newly connected device in the network. So when I connect a new device and when this is selected on that option, obtain an IP address automatically, this device now starts broadcasting a signal called the discover signal. How does it do that? Now this device sends a packet on the broadcast IP. Whenever a packet is sent on the broadcast IP, broadcasting is sending a packet from one device to all devices. Okay, from one to all is called broadcasting. So this device now sends a broadcast signal. Oh, sorry, my bad. So now this sends a broadcast signal to every other system in the network. And this signal is called the discover signal. So basically it is trying to figure out who the DHCP server is. It's asking every system in the network, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When it reaches the wrong devices, they just block that packet. They don't respond to it at all. But when it reaches the correct server, that server responds back saying, hey, I'm the DHCP server and I can offer you an IP. You were looking for me. I'm the DHCP guy and I can offer you an available IP in my pool. So let's say 192.168.0.4. Okay. Once that offer is made, your client says, he gets so happy and he says, hey, thanks for offering that IP to me. I would request you don't allocate that IP to anyone else in the meanwhile, and just allocate that IP to my system. So there's a request sent now, so that this IP is allocated for sure to the client, to this client itself. And for that, your DHCP server sends an acknowledgement back saying, hey, I've got your request. I acknowledge that request. And with that acknowledgement or confirmation, so this is the acknowledgement here. With that acknowledgement, this system gets the IP 192.168.0.4. Okay. And that IP again is removed from the pool now here. So now the new pool begins at 0.5 instead. Okay. And this entire process of discover, offer, request, and acknowledgement is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And I'm pretty sure you must have observed this at least once in your lifetime. Okay. Whenever you connect your phone to a Wi-Fi router, so let's say if you enter your password and click on connect, for a very short duration, you see a message called obtaining IP address. Not sure how many of you have ever observed that, but that is basically where your phone is communicating with the Wi-Fi router and performing the DORA process to get an IP address. Okay. If I had to show you this practically about the DHCP server, I can log into my router here actually, 192.168.0.1. I'm using a TP-Link router over here at my home. If I log in with my credentials here, you would notice this is my network settings. Yeah. So my Wi-Fi router, my TP-Link router itself is acting as a DHCP server. First IP in the network is always assigned to the router. And here you can see there's a pool of IP addresses from 0.2 to 199. So I'm not using all the 254 IPs. I've limited it up to 199 itself. Okay. And from that pool, each unique IP is given to a unique system. 2, 3, 4, 5, 6. You can see each IP is assigned to each unique device over here. Okay. So that's what DHCP server is. Any questions, any doubts up to this point? Anyone? Muktesh, Shivnarayan, Srihari, Sohit, regarding what a DHCP server is or what a DORA process is.
So, what I understand, if user wants a dedicated IP address, he will do the manual setting. Otherwise, if he'll go for DORA process, so whatever IP address is free or available, that will assign automatically to
Exactly.
that, right?
Right, exactly. So if you want a static IP, if you want to assign an IP specifically for your system, allocate or dedicate an IP to your system, you have to assign it manually with the static method. If you're okay with getting any IP randomly available from the pool, you can go for the dynamic method, the DHCP server method.
Okay, got it. Thanks.
Right. Muktesh, any questions? Srihari, any questions? Sohit, any questions?
I have a question. So what happens in the backend if we manually assign an IP for ourselves?
What happens in the background? Sorry, come again.
So what happens in the background when we assign a static IP for ourselves? So does let's say we're assigning IP address for our device. Let's assume it's 192.168.0.3. So what
Okay.
exactly happens in the background?
Basically,
How it
you have
gets
something called
removed?
as a MAC address. So again, if you open up your command prompt, and if you type something called, I've not covered this yet. We will be talking about this later on as well anyhow, but just a glimpse on it. So if you type ipconfig /all, you can see there's something called as a MAC address as well, if you notice over here. Okay, so this MAC address is basically assigned to something called my NIC cards adapter. So I'm using a chip called a wireless adapter here called from Realtek. Okay, and this chip here is available on a NIC card here. If I type a search for NIC card, this is what an NIC card looks like. Okay, this is the main chip responsible for all your network interfaces or network components. Okay, so on this one chip itself, you have all your networking components. You have the Ethernet port here. Oh, 1 second, still loading up. Open image in new tab. Yeah, as you can see, This one chip has the Ethernet port, it has the Wi-Fi chip, it has a Bluetooth chip, whatever it be. And each of these unique chips here has a unique MAC address. So when you're assigning an IP, that IP is getting allocated to your system's adapter here. So this is fixing it for this certain adapter, and this is what is being used to connect to the other devices in the network. So when you're assigning an IP manually, you're giving the IP yourself to this chip yourself. Okay. If not, if you go for DHCP, the DHCP server allocates an IP to this chip for your system. That is what is happening in the background. I hope that was your question. So
yeah. So let's for that case, since the same example, let's say I'm assigning my device an IP of that 192.168.0.3.
okay.
So will this particular IP be removed from the DHCP server?
It will definitely. If you're assigning that IP yourself, that will again be added in the DHCP pool itself, that this IP has already been assigned to another system. So now that IP cannot be used. If that IP is already assigned in the network also, then your system will get an error saying IP conflict error. This IP has been already assigned in the network, so you cannot assign it to your device. Okay. So once you are assigning an IP yourself manually in a local network, that IP will also be added to the DHCP pool as well. Okay. So all your systems will communicate. So your DHCP server, your Wi-Fi router also acts as a switch. A switch is a device which connects all devices together. Okay. And the switch basically gives an ARP update. So address resolution protocol update, which tells these all IPs have been used. Okay. So this is my router, this is the last broadcast IP, etc., etc. So every system has an update on telling what IP has been used up already and what IPs are available. Okay. So when you're adding an IP yourself, if you're assigning an IP yourself, the DHCP server gets an update. Okay, this IP cannot be used because it has been already assigned manually by other systems. So I have to use the other IPs available in the pool. Okay. So this is called as an ARP address resolution protocol update. This is sent by the switch actually. Now too many devices. So your Wi-Fi router is acting as a switch, acting as a DHCP server and a Wi-Fi router itself. Okay. So the main job of a switch is to handle and understand which device is what IP on what MAC address. Okay. So that's an important point to note.
Okay, thank you.
All right. Moving on. So again, that was a bit off topic, guys. Don't get confused. We'll talk about all these things in the upcoming sessions. What address resolution protocol is, what an NIC card is. I'll talk about NIC card in this class itself, in this session itself. Okay. But that's about DHCP server. Okay. How does a system get an IP automatically? This is one way. Or if you want the older method, you can assign it manually yourself as well. Okay. By going to the control panel and assigning the IP yourself. Okay. Moving on. So we talked about DHCP server. There's one more protocol called DNS protocol. What is that now? So if you remember, we assigned IPs like 8.8.8.8 and 8.8.4.4, and they were Google DNS server IPs. But what is a DNS server and why do we need it? To understand about DNS server in a very simple way, this is the internet's phone book. So just like how you have a contacts app on your phone, what does this contacts app do? It links a phone number with a contact name. So you might have my phone number in your contacts app. You could have saved it with any name, cybersecurity trainer, DURGASOFT trainer, Shoaib cybersec, whatever. For your SIM card, when it needs to dial up my number, it's irrelevant what you save the name as. The name is only for your relevance, okay, for you to remember who this person is, okay. For the call to get initiated from your phone to my phone, the only two important factors here are your 10-digit SIM card and my 10-digit SIM card, because that is what the connection gets placed on, okay, not on the names. Name is only for your remembrance, okay. Similarly, when you go to a browser, and in a browser, when you search for www.google.com, your browser doesn't understand this language actually, and it doesn't even care what google.com is. What it needs is exactly the public IP of the server on which this website is hosted. So somewhere on the internet, there's a server here, google.com, again, a server here with a certain public IP. And on that server, you have Google website hosted. Okay. So it needs the exact IP address for that. And on the internet, you have something called DNS servers. They're mostly maintained by your ISPs itself, or they can be maintained privately by organizations like Google. Okay. And in these DNS servers, you have records. Okay. These records are called as host records, and they give you information on what domain is connected to what public IP. So google.com is hosted on so and so public IP. Bing.com hosted on so-and-so public IP. YouTube.com hosted on so-and-so IP. Shro.com hosted on so-and-so IP. Okay, so basically, a DNS server has a linking of every domain name and its exact correlating IP address. So when you search for google.com, the request comes to the ISP. ISP forwards it to a DNS server. From the DNS server, you get to know, okay, google.com is located on this IP. And from that IP, the traffic reroutes to that certain server. So with the help of a DNS server only, you can resolve what a domain name is to its exact IP and reach the intended web server. If I show you an example for this, I can open up my command prompt, and here I can run a command called ping, www.google.com. Ping is a command which sends something called ICMP packets, Internet Control Messaging Protocol packets. Okay, so it sends packets to that certain server and waits for a response. So as you can see, I'm getting a response back from an IP here. If I copy this IP now, if I go to my browser, and in my browser, if I search for that IP and if I hit enter, carefully observe, I get the Google website. So here, when I was getting a reply back from so-and-so IP, I was getting the reply back from Google's server. Okay. So when you're pinging to it, you're getting a response back from that server's exact public IP. So if a DNS server was not existing, you would have to remember this IP, a similar IP like this for every unique website. Okay. But you don't have to do that today because the DNS server is resolving or converting those IPs into domain names. Okay. So the main job of a DNS server is to link a domain name with its exact correlating IP so that you can reach the exact server. Okay. So whether you enter the domain name or whether you're entering the IP, you're reaching the same exact server, all thanks to a DNS server in the background. Okay. Is that clear? Muktesh, Shivnarayan, Sohit, Srihari.
Yes, yes.
Right. Muktesh, any questions? Sohit, any questions? Srihari, any questions?
I'm good.
No, sir.
All right. Moving on to the last concept for networking, we have something called special IPs now. Okay, so there are two categories of special IPs. One is loopback IP and one is a PIPA IP. Okay, so these are neither public IPs nor private IPs, guys. Okay, they're not used for networking. They're not used for sending data or again, basically communicating with other devices. They're only for troubleshooting. Okay, what I mean by troubleshooting is if there's any issue with your network, you can figure it out with these IPs actually. Okay, so the first IP, loopback IP, is basically ranging from the number 127.0.0.0 to 127.255.255.255. So the entire network of 127 is the loopback IP. Okay. And this cannot be, again, this is not basically assigned to any system. Okay. It is self-assigned by the device itself, by the operating system itself. Okay. So your system's NIC card has the loopback IP. So all the IPs from 127.0.0.0 to 127.255.255.255 linked to your own NIC card itself. Okay. And this is only to check if your NIC is working properly or not. So if you go to your terminal or your command prompt and you run a command called ping 127.0.0.1, and if you hit enter, you get a response back. You should get a response back. When you're getting a response back, it basically means you're sending packets to your own NIC card here, and you're checking if your NIC card is responding back or not. If it is responding, it means the NIC card is functional. It's working properly. If you do not get a response back, it means your NIC has malfunctioned and you have to get it replaced. If you don't, your system will not be able to communicate with any other system. Okay. So loop back in the sense you're trying to ping your own device. You're looping a connection there by pinging back to your own system. Hence the name loop back. Okay. Used for internal testing on a device, data sent to this address is looped back to the same device. Okay. This is the address of your own NIC card. So if you were to ask me, this was a huge wastage of IPs. So you can ping to any IP in the 127 range and you get the same response actually. 55, 65, 250, any random number, you get the same response. Okay. So if you were to ask me, this was a huge wastage of IPs itself. But again, this is built the way it is, so we can't change that. Okay. And then you have APIPA, which stands for Automatic Private IP Assigned Addresses. So these range from the number 169.254.0.0 to 169.254.255.255. Okay. And these IPs are assigned automatically to your device from the operating system. So whatever operating system you might use, Windows OS, Linux OS, Android OS, whatever it be, these IPs from this range are assigned by the OS itself if your system is not getting an IP from other sources. So what are the other sources again? Your system can get it either manually by yourself or can get it from a DHCP server. So these are the two sources from where your device gets an IP. And if both of these sources are failing to assign an IP to your system, in such a scenario, the OS itself, the operating system itself, will assign a PIPA IP, 169.254.0.0 to 169.254.255.255. So if you get any IP starting with 169 as a private IP, it means your system is not able to retrieve an IP from both the sources, manual and automatic sources. That's what you have to understand from that. Okay. These IPs are not used for communication. You cannot communicate with these IPs. They're only used to indicate that something is wrong with your system's IP. Okay, something is wrong with the NIC card or so. Okay, that's all, nothing further. Okay. Now, an assignment for you, a small work for you is to basically understand what CIDR is. Okay. So basically, there's a concept called CIDR, classless interdomain routing. Now, I won't be showing the slide for this, guys, okay, because this is an assignment for you. So if time permits, try to understand, try to research what CIDR is, and we'll discuss about this in the next class. So that's the last topic, actually. Okay, nothing further left out for networking. Okay, so yeah, that's that. Any questions, any doubts also up to this point?
Sir, if hello,
Yeah, Muktesh. Yeah.
sir, if loopback IP 127.0.0.3 not working from ping, then it only works for a LAN or Wi-Fi also, sir.
If one part of the NIC is not functional, the entire NIC will be not functional, Muktesh. Okay, so that one single chip itself contains all the network interfaces. Okay, so if anything is wrong with the NIC, all the interfaces will fail.
Okay, sir. For one more, sir, if any organization have, and I mean that the organization not maintain the server, sir, but
Okay.
the organization containing more than 255 systems.
Okay.
So the DHCP, how it will working, sir? There will be chance to conflict for how many days, sir? I mean
You
that
have, again, if you have more than 255 devices, you would configure class B IPs, Muktesh. So rather than giving 190 to 168 something, in the DHCP pool, you have to start from 170 to 16 something, because that's a class B. And in that class B network, now you can connect 255 into 255 devices. Okay. And there is no time limit, like you can only connect these many devices for these much time. Okay. So there's something called a lease time. So lease time is basically once an IP is assigned from a DHCP server, that IP stays on the system for that lease time. Because if you shut down the system in between, that IP should not be wasted. So after the lease time, the IP goes back to the server again, and your server performs DORA one more time. Okay. If the system is available, it gets the same IP. If the system is not available, that IP goes back to the server. That's what lease time is. I think it's visible here in my browser. So if I go to my, oh, I think I logged out. 1 second. If I log in back again to my router in my DHCP protocol, you can see there's something called as lease time, 1440 minutes. This is 24 hours. Okay. So for 24 hours, so as you can see, this is the lease time given for each system. So for next 22 hours, 51 minutes, this system, Redmi Note 13, will get the IP 192.168.0.5. After the lease time is expired, this system now needs to perform the DORA again. Okay. If the system is active, it gets the same IP. If the system is inactive, that IP goes back to the pool here. Okay. And it can be assigned to some other system. So that's what a loose lease time is. And if you have more than 255 devices here, you have to assign 172 16 dot something something. Okay, that is for class B. Okay. In that scenario, you can connect more than 255 devices. Okay. Is that clear?
Yes, sir.
Right. Any other questions? Anyone else? Muktesh, Shivnarayan, Sohit, Srihari.
So loopback is like one network and 3 hosts, and a PIPA is 2 network and 2 host
There
class.
is, again, when you talk about these IPs, Shivnarayan, these are neither public IPs nor private IPs. Since they are neither public nor private, they do not have any network portions and host portions. Okay. The host portions and network portions are only for private IPs. In class A, class B, class C, whatever private IPs you have, for those private IPs only you have network and host portions. Okay. You don't have network and host portion for public IPs and not for neither for special IPs as well.
Okay. And one question I may have missed yesterday's session. So I am a functional tester. So is that course useful for me, or I am in the wrong room?
Again, the main objective of this course, basically, as mentioned, Narayan, is no matter what domain you come from, if you're planning to shift into cyber security, if you're planning to learn penetration testing, testing the security of web applications or again, third-party applications or network security, wireless security. So if you're interested in testing the security aspect of any endpoint, this course is the go-to course. There is no other course better than this one. I can guarantee you that. Again, as mentioned, the limitation here is if you want to get into the security aspect of your endpoint, okay, whether it be whatever endpoint, whether a web app, your third-party system app, okay, or your network devices, your firewalls, your routers, okay, whatever. Okay, so if you want to test the security aspect, this is the course. Okay, so as a functional tester, what apps are you testing again, Narayan?
So yes, so I am into like functional testing of web application, mobile application,
A will
and
be a
what
helpful course for you,
system.
Narayan, because we do cover some vulnerabilities in websites as well and web applications as well. So if you want to again expand on more knowledge on vulnerabilities for testing in websites or web apps, this is a go-to course. We'll be covering some very important topics from website pen testing in this course.
Okay,
Right.
thanks.
Sure. Any other questions, guys? So with any questions? Shiv Narayan, any
No
questions?
questions.
So yeah, that's that. Nothing further for the session today, guys. Please join the session tomorrow as well, because tomorrow it's going to be our first practical session where we talk about how do you set up the hands-on lab. Okay, so we need to set up a lab called the VMware Workstation Lab, in which we install a tool called Kali Linux. So tomorrow we're going to talk about how do we install VMware, and within this VMware application, how do you install the Kali Linux OS. So we'll be talking about that in the session tomorrow. A very important one, a very practical session. So no more theory from tomorrow. This is what we'll learn in the session tomorrow. So please do join tomorrow without fail. Okay. Bye-bye. Good day. See you soon. Take care, guys.